Okay, so Business Algebra Chapter 8 is all about sets and probability. So 8.1 is kind of heavy on concepts and not very heavy on math, which you can look at that in a number of ways. So a set is a collection of distinct things called elements. For example, the set of vowels you can think of as the set of the elements in the set would be like A, E, I, O, and U. Sets can use quite a large number of symbols. It turns out that mathematicians in the end are lazy and would like to convey the information in as little effort as possible, so they use a lot of symbols to represent words. Sets can be described in a few different ways. The main way you're most likely going to encounter them is what's called set builder notation. So when you see something like A equals and then a brace and then X and a line, this really says A is the set of all X such that X is a day of the week in language. So the brace represents set, the braces, and the X with the bar and X is the X set of all X such that X is a day of the week. So just keep that in mind when you're reading it and what it really is asking you. So key symbols, this little curly looking E thing means is an element of. So when you see 2 and then is an element of A, which just means 2 is in the set A. The empty set, which looks like a circle with a line through it, is a set with no elements in it. So let's just practice here what's happening. Let A be the set 2, 4, 6. The dot 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 means the pattern continues up until 24. So all the even numbers from 2 to 24 determine if these are true or false. Is 2 an element of A? Yes, so this is true. Is 10 not an element of A? This is false because 10 is actually in the set A. Now, this says the set containing 4 and 6 is an element of A. So this is tricky. Even though 4 and 6 are both in A, this is the set containing 4 and 6, which is something different entirely. So this is something that they do to try to trick you. This is false. When you see these braces around it, it can mess with it. It creates subsets and not necessarily elements. Unless you see 4 and 6 together in braces in A, then it's not going to be there. And then the 10 and 20 is not an element of A, so same argument here, except this is not an element of, so this is true. Yeah, so when you see a line through the element symbol, that means not an element of. Now, we also have subsets. So the key symbols for subsets are, it almost looks like a less than sign, but it's a rounded upper portion. It means it's a subset of, A is a subset of B. What that really means is that if there's any element in A, that element must also be in B if it's a subset. So basically B is like a bigger set containing everything A has in it already. Okay, so technical definition of subset is A is a subset of B if and only if there's an element in A implies the element is in B for any element in A. So let's do some more true or false. The empty set is a subset of A. Okay, so first off, the empty set is a subset of everything because it has nothing in it. So anything in the empty set is of course an A because there's nothing there to prove that otherwise. Is A a subset of the empty set? This is generally false unless A is the empty set. So generally speaking, the empty set is always going to be a subset of anything else. Nothing else will be a subset of the empty set unless that set itself is the empty set. A is not a subset of A is false. Any set is a subset of itself. And if X is an element of A, then X is an element of B implies that A is a subset of B. This is true. What this is saying is that anything in A is also in B, which is what implies subset. Okay, there are symbols that go between sets. One looks like a U and one looks like an upside down U. If you've done domain before, you may have seen the U. The union of two sets, A union B, contains all of the elements of A and all of the elements of B. It's associated with the word or in the English language, because when we say if it's in A or B or both, then it's going to be in the union of the sets. Again, you can think about this from a marriage perspective. When two people get married, or they bring all of their stuff together, and then their household has everything that one had or the other. Now, you only have to list anything once, because if both people brought a microwave, you probably only keep the better one. The intersection of two sets is the upside down U, contains all the elements that are in both A and B. When you think of intersection, when you talk about people's interests, you often try to find things to talk about, and it's things that usually the intersection of the two things that you guys enjoy. And it's associated with the word and, because you have to be A and B to be in the intersection of A and B. So we'll find the union and the intersection of the following sets. A is -7, -3, 1, and 5. B is 1, 5, 9, and 3. So for the union, which is A union B, you just take everything that you see and put it down in the set. You don't need to put repeats. So everything gets joined here. -7, -3, 1, and 5. I don't need the next 1 and 5, and then 9 and 13. For the intersection, I'm looking at what the two sets share. They share a 1 and a 5 because they both have one. And here, the second one, B, A is A, E, I, O, U. The vowels, B is C, D, F, and G. So when I combine them together, because they don't have anything in common, I'm just going to take all of the elements and bring them down. But when I look at the intersection, I ask myself, what do they have in common? Nothing. So I can either write this like this with nothing inside it, or I can write it as the empty set. If two things don't have anything in common, their intersection is the empty set. Okay, let's continue. Okay, so when we talk about U means the universal set. And we'll talk more about that as we go. It's like your boundaries. It's like your sandbox. All of the sets are going to have to play in the sandbox, and U is defining what the sandbox is. You can't go out of the sandbox when you're making your set. You can think of it when we get to the Venn diagrams in 8.2. It's the rectangle on the outside of the Venn diagrams. That would be your sheet of paper. So U is the set of all x such that x is an integer. So basically U is all of the integers, and A is all the integers between 5 and 20. Find A, what looks like apostrophe. So when you see A apostrophe, this means a complement. So it's everything that's outside of A, but that's still in the universal set. So basically, I need to take all the integers and remove all the things between 5 and 20. So that would be, A complement would be, -4, -3, -2, keeps going until you hit 5. And then it jumps to 20 because, of course, if A had all the numbers between 5 and 20, then this one has everything but the numbers between 5 and 20, 21, 22, and it keeps going forever because of the way the integers work. So you can use the ... to imply that things are just going to keep going. Now, lastly, in 8.1, you'll have the number of subsets. The number of subsets you're going to have is always equal to, you can think about it this way, if you look at each element individually, it's either in the set or it's not, which is 2 options, which means the total number of subsets is 2 to the n, where n is the number of elements in that set. So find the number of subsets of A, given A is the set, A, B, C, D, E, F. Well, we know the number of elements of A is 6. So this is a shorthand way to write number of elements. That means the total number of subsets is 2 to the 6th, and 2 to the 6th is 64 subsets. And that is all for 8.1.